basically what we do is we'll install a small agent. This agent will take care of provisioning. So basically we'll set up your network, we'll spin up your EKS, it'll spin up the storages that you need by default, and then, getting everything set up for you in Kubernetes. And then everything is within your VPC. And then this agent doesn't get any requests. The traffic doesn't go into the agent itself. The agent does the pull. So it pulls data, it pulls requests, it pulls instructions from our control center, from our control plane. So there's no incoming connections into the cluster. So basically that makes it a lot safer.
We don't use an agent, but we basically said, okay, let's use the AWS Marketplace, and it kind of does the same thing. Say I need a cluster, 3 nodes, whatever, and it will automatically deploy it all for you. Hello everyone, welcome back to this week's episode of simplyblock's Cloud Commute podcast. Again, like every week, another incredible guest. Actually, one guest that I think I haven't met before, in person at least, which I know is not like the typical thing I'm saying. But welcome to the show, Christina. Glad to have you. And maybe just introduce yourself real quick. Who are you? What are you doing? And why do you think I invited you?
Actually, that's one of the questions I want to ask, Chris. So hi, everybody. I'm Christina Lin, and I'm currently a developer advocate in Redpanda Data. So basically what we do is we are a replacement of Kafka to make it simple for you to kind of understand what we do. And before that, I was working in Red Hat for 10 years straight, doing I started in JBoss, which is a Java web server, like in the very old days. And then I switched to do some kind of like the integration work, ESBs, because I was doing that before Red Hat, and I did Apache Camel. So I did a lot with the community. I still love the community, by the way, Apache Camel. And then I moved on to do some kind of content on Kubernetes, because at the time we're running a bunch of like our integration applications on top of Kubernetes. And of course, Red Hat has its own version of Kubernetes, OpenShift, of course. So I did some of that. And then now I end up here doing a lot of the Kafka and streaming related content here.
That's interesting. I didn't even know you were at Red Hat. Seems like I actually had the right t-shirt. It's one of the Spirit Animal series years and years ago. Right. Cool. JBoss. Wow. That is very ancient. Any kind of application server is very ancient.
I started my job when there's not even like a web server, right? So and I was using WebSphere, WebLogic. I don't know if you recall these names, but yeah, we were using all those before, very early on.
For the audience, in case you don't know, you haven't missed anything. No worries.
Yep. I have to say, yeah. You don't want to know those.
Glad we agree on that.
Yep.
All right. You already said you're with Redpanda right now. Redpanda being a re-implementation of the Kafka protocol, I think based on C++ is one of the ideas, right? Getting rid of the JVM as like the underlying technology.
I think, like for people that's familiar with Java, like me, I started programming in Java, and some of those I started with assembly code and then Java and stuff like that. But like one of the hardest thing with Java is its garbage collection, right? So if you want to have a very, efficient running Java, you have to continuously, especially if it's a long running service, you need to continuously tune your garbage collector, the heap sizes and all that. So, if you tune it very well, if you know what you're doing, you can actually have a very efficient running Java program. But the problem is, I think people writing Java and the people hosting your Java services is two different types of people. So then you've got this SREs and operation people that's, managing your services. And it's been doing that for like the past 10 or 15 years when I'm in the industry. Like the people don't know what Java is. There's a bunch of people that, that helps with, getting, the Linux running, they're hosting your Java application. They don't really know how to tune your JVMs. And so for having that available and having that efficient running, it's just a lot of work. And I think that's why I kind of really like what Redpanda is doing, because it's taking away all the complexity. It makes it simple and easy for people that's managing the service. So they don't have to think about, what's the memory management problem right now. So all they have to do is just running that single binary application that will just work. And that's what I like about Redpanda.
That makes sense. I mean, I moved to developer advocacy years ago. I've done quite my good share of like garbage collection optimization consulting. So go for it, take it away. I don't need to make money out of it these days.
Exactly. When I was a JBoss consultant, most of my time is spending like teaching
Yeah.
people how to fine tune their JVM, right? So
I always loved how Oracle WebSphere had the perfect garbage collection parameters in their documentation, because that was what people were asking for, and I was like, yeah.
It never worked out for us. We have to always kind of figure. So we have to get all these tools and monitoring our garbage collection, looking at our memories to fine tune it ourselves, right? There's no like one size fits all solution for all that. So I think similar to that, when you're deploying your Kafka cluster, apart from setting up you gotta set up like your Zookeeper to keep track of the distributed systems, and then all that crazy stuff that happens. I think when Redpanda came out, it doesn't have all that. So that's why I really like it.
I think Redpanda might be the one reason why KRaft mode actually exists, like the Kafka Raft without Zookeeper. I think you actually made that happen, because it seemed like nobody cared before. I hate Zookeeper with a passion. Like, I can't even explain how dirty I feel if I would have to touch Zookeeper.
I mean, yeah, it's fine. It's Zookeeper is fine until you need to change your IP addresses, and then everything, or your network setting, and everything just go berserk after that. So because in Red Hat we had our own version of Kafka before, so it was also using open source Kafka. So I had a chance of like playing with it, and I just don't like it so much. Yeah, and
I don't know. I wouldn't call Zookeeper simple. Even just like, even if it works, it just looks so unnecessary compared to something like etcd or whatever kind of stuff, right? All right. So Kafka streaming data. Why would you need that? I mean, I have an idea, but the audience may not.
Right. I mean, it's always about like when you were talking about communications in the behavior of application, you always got like two things, right? Synchronous and asynchronous. And for asynchronous, you want to have like confirmations and acknowledgement right back to your request, right? But there's always another type of communication where you want to just like tell people, hey, this is what I'm saying, and then you get a bunch of other subscribers. So people has been doing that for a very long time. Like before Kafka started, we have our messaging system, right? Like MQs and all that. Like that's way before. But I think what Kafka brings is the ability to scale, right? Because I don't know if you have ever installed or helped managing a messaging system. The way that it does, the guarantees of deliveries, the way that it does the backups. I think at the time when I was doing it, we're doing a lot of active MQs, when we're doing a lot of like MQ kind of content. They're all stored in the database or different storage. But in order to actually do the distribution in a much more native way, Kafka makes it a lot easier to scale, because it's basically doing replication across all the different nodes in the network. So the way that it does, it allows you to scale infinitely, and being able to, and because of the way that it can scale infinitely, you can actually get more, ingest more data in a much more scalable way. And it kind of fits into the cloud native world as well, because cloud native is all about scalabilities. It's all about like, flexibilities and, ability to actually increase your instances being scalable. So I think that kind of came in the right time. So that's why it took off. And then people are now thinking like, hey, instead of like doing a response and waiting for that, very slow communication patterns, why don't we just do asynchronous and keep sending, like especially with devices like IoT devices and edge devices, they have a huge volume of traffic. They're just trying to get into the system. There's no way that they can do this request and response anymore. So this asynchronous way of like communication makes sense. And there's more data coming in. That's why we need the streaming data to be able to handle all the load on the internet, like the requests that we're getting today. So that's basically what people are using it for. Other than that, I think we have been using, messaging system for, enterprise service bus before, but now we have microservices. And for microservices, you don't want everything to be as request and response, because that becomes very sticky. So you want it to be more event driven, and to build that event driven backbone, you need to have a asynchronous way of sending your data around the entire system. And that's where you also find the use of the streaming platform as well. So that's kind of where I see also happens as well.
Yeah, I think that makes sense. What I loved as an example in the past was you order something on an online shop, like a big online shop having thousands and hundred thousands of orders at the same time. But you get a confirmation email, confirmation message on your phone, whatever. But both things normally take about like a minute to maybe 10 minutes, because it is exactly that. You put it onto a queue, and an email sent might just take a second, but that means the second you can't do anything else. So it piles up a little bit, but it will eventually get around to you and say, okay, now it's your time.
Exactly. If you get an order, if you store it directly into a database, that makes sense, right? That's how people store their orders. But like in today's world, we have multiple different systems. They all want to react on that particular order. So this push notification, this pushing way of notifying the consumers makes a lot more sense.
Yeah, exactly, right? You order you store the order immediately, and you at the same time send off the message like, hey, there was a new order. Whoever wants to do something, go ahead. Redpanda, I think you started as a standalone service, basically being installed on an on-prem system or whatever you want to call it these days. But there's also Redpanda Cloud for 2 years, maybe a year and a half or something, maybe more.
Around 2 years, yes.
Okay.
So there's a lot going on in Redpanda, because I think we've been trying to evolve into something that actually people want, different type of services. So we started with like self-hosted, like you run your own Redpanda or just work, and developer loves it because they like to run it in their own laptop, because it's very small, very tiny, simple binary, like it all works. But then we started to see people wanted to have it help managed, because of course managing a distributed data system is not that easy. So we started doing all that for people. And then we found another need from our customer that we call it like BYOC. BYOC meaning bring your own cloud. So basically what that means is that we'll deploy our own cluster, into your cloud environment. So the actual user or the enterprise does not expose their data outside of their own realm, right? So everything is within their VPCs, everything is kind of within their control. And the way that we did it is very smart. So basically what we do is we'll install a small agent. This agent will take care of provisioning. So basically we'll set up your network. It will spin up if you're on Amazon, you'll spin up your EKS, and then you'll spin up the storages that you need by default, and then getting everything set up for you in Kubernetes, and then everything is within your VPC. And then this agent doesn't get any GET request. The traffic doesn't go into the agent itself. The agent does the pull. So it pulls data, it pulls requests, it pulls instructions from our control center, from our control plane. So there's no like pushing in.
There is no incoming
connections.
Yes.
Incoming connections into the cluster. So basically that makes it a lot safer.
Okay. Interesting. That is we don't use an agent, but we basically said, okay, let's use the AWS marketplace, and it kind of does the same thing, right? You say I need a cluster, 3 nodes, whatever, and it will automatically deploy it all for you.
The different thing is we manage the cluster within your cloud. So when you do that with marketplace, when you spin it up, you don't actually manage the patching. You don't manage everything. The customer has to come and do a little bit like on their own.
Yeah. Okay.
But for BYOC, everything is managed through our control plane. So whenever there's a patching that needs to be done, whenever there is something that needs to be updated, that our agent will be notified. But we don't do that right away. We'll have to check with the customer and says, hey, do you want to do your updates today?
Right.
Is there anything crazy is happening? So we'll do that for them then.
Oh, that's interesting. Yeah, we do connect to our control plane, but we do not do patching of the virtual machines, I think.
Right.
That's a good point though. I never thought about that.
Yeah, it's basically a managing service, but in
Right.
your own cloud environment. And then we also have this new services that came out like a year ago. It's called serverless. So it's basically getting your own topic running. So it's basically a managed service, but
Oh,
like on our own. And then we'll give you like a virtual cluster instead of an
right.
actual cluster. So you're working with virtual clusters. And some people like virtual clusters because they can divide their different functions, different departments, like different things like in their own cluster. So they're like independent, they're isolated. So you're not seeing other people's work and other people's topics.
That makes a lot of sense. The thing, and we already talked about that the thing that I loved most about Redpanda was how easy it was to set up. I think one of the first times we talked was actually because I was building this CDC tool specifically to timescale, and obviously because it's basically Debezium compatible, I used Kafka, but I didn't feel like the fun of setting that up. So Redpanda, it was. I mean, eventually it was like all test containers, and Confluent or the Apache Kafka team just came around with the like craft mode. But Redpanda was like so much easier, and it's actually starting up like so much faster as well. It's insane.
Yeah. People notice the difference when they start up.
Oh yeah, I can very much say that. Yes.
Yep, exactly.
So for me, it was in the end, it was like test containers. The test container setup was like, okay, I try with Apache Kafka, but most of the tests run with Redpanda because it's just like so much faster.
Right. Well, even with test containers, I don't know if you noticed, but test containers, when I first saw test containers or similar ideas in that is with when I was in Red Hat, it was way back in the time. So there was like a new Java framework, Quarkus. So Quarkus has this idea of like spinning up test container like testing environment for running your unit tests and stuff like that, right? So, and when I saw that, when I was doing one of the Kafka examples, and I saw they spin up a Redpanda service, and I was like, what is that? Why don't you use Kafka? And what is that? And that's when I know where Redpanda is. So we work closely with the test container as well, and we support like not other than Java, but we support other languages like Golang and all that for them as well.
But by the way, for the audience, we're talking about test containers here. We had Oleg just a few weeks ago. I'll put it somewhere, whatever, right? You find the link in the show notes. For the Redpanda cloud in itself, let me guess, there's Kubernetes underneath. Is that how the magic works, or do you also use the agent to set up like the well, you said it's EKS, so it probably still is Kubernetes.
Yes. So for the managed service, the BYOCs and the serverless, everything is running on top of Kubernetes. So we do support 3 flavors now, like EKS, GKEs, and like the one on Azure AKS, right? So we do support all 3 right now. So they all run on top of Kubernetes. And then some of our customers, they run on bare metal if they want like extreme like performance. If they want to do that, like of course you can't really do that with like a virtualization like technology, right? If they want to like super bare metal, they'll just run it on bare metal machines.
I think that is not 100% true anymore. Like in the past, when the like hyperscalers didn't have like the dedicated resource virtual machines, that was very much true. With the at least my experience is that if you go for like dedicated network bandwidth, complicated word, network bandwidth, or and dedicated CPUs and stuff, or virtual CPUs, you're normally pretty like predictable in performance and very consistent in performance. But you pay for it. I mean,
yeah, of course.
You could probably take your own hardware for that price, so
exactly.
it's all fine.
Well, the thing about bare metal is like because how I'm just saying like squeezing out of all the juices out of the hardware. I'm just saying like if you're running Kubernetes on top, you need to kind of dedicate the way that Redpanda writes, because we're running everything in C stars. So the way that we allocate the memory is that we will pre-allocate a amount of memories, like so that we will do the memory management for you, and then we'll pre-allocate. So we'll just hold on to all the threads in our CPUs. So if you're running on a machine, right? If you don't dedicate everything over to Redpanda, that means that because you're running Kubernetes and other services on top, you still need to kind of dedicate a few more cores and memories for that. So that's what I meant. But yeah, in Kubernetes, it's easier to scale out. So like this is a trade-off.
Yeah, okay, that's fair. I mean, it's kind of the same thing that I keep telling with people with databases. I mean, if you have a small database, running on Kubernetes is fine. And it's totally fine to also have it on a shared system. If you have a database under load, it's still fine to run it in Kubernetes. Don't get me wrong. I mean, the orchestration is still awesome. But you really want to have like a pinned node, tainted so that nothing else except for like the bare minimum of Kubernetes services and the database is running on that. And you're basically dedicating a whole node to your database. But you would do that either way.
And then you have like tens and thousands of services and things to look after. Of course, I want to go to cloud native because I can have all my code like under control with GitOps and all that, right? So it's like different trade-offs and things.
Right. I think we answered that question just so slightly before, but why would a customer typically choose Redpanda over something like Apache Kafka or Confluent Kafka or any kind of other Kafka distribution?
Well, first of all, I think it's healthy to have some options in the market. I don't think it's always good to have one dominant technology because, it will never go forward. So it's good to have some competitions, right? So that's first thing. And then why would people choose over Redpanda over Kafka? I mean, it's all about choices. And like for me, the choice is all about simplicity. Right, so how fast I can get one services running, how fast I can get that thing working, and how easy that is for me to operate on my environment. That's like the first thing I can think about if I want to go for Redpanda, and that's why I choose Redpanda over Kafka. And of course, you can always have the same kind of like performances on using different technologies, but the effort that you need to put in to run a Kafka cluster compared to what you have put into a Redpanda cluster is totally different. And that's one of the best thing about it. And I think one of the things that we're currently working on is we acquired an open source project called Benthus a couple of months ago. So this one is kind of a similar technology for integration. For that, I mean, like we can do Kafka Connect related operations, like things for so we can actually stream data from databases. We can stream data to S3, all this different data source to Redpanda or different Kafka streaming systems, right? So we can do that. And the difference is that it's written in Golang. It's also a single binary. So it's all about simplicity. So you don't have to stand up like a connector. So if you want to start up a connector, I'm pretty sure because you said you did something with Kafka Connect. So you have to add the libraries into your Kafka Connect, like Kafka Connect container. If you're running a container, you need to add libraries. And then you have to configure that with JSON, and you need to know all the like the Java package, like all the Java package for all the different endpoints, and then you configure that and that works. But for the Redpanda Connect, it's basically just a decorative file with YAML. So it just tells you, okay, I'm connecting from Kafka to an S3, and these are all the things I need to put in. It will just do that itself. And it's because it's written in Go, so it's a lot lighter weight, and then because Go has Go routines, so it's easier to kind of scale it out. So that's kind of what we're working on right now.
Okay, because we crossed the 20-minute mark already.
Oh, okay.
How would I get started? What's the easiest way? Docker,
okay.
Kubernetes.
The easiest way to just come to our getting started page, and then you'll find our how to get started. And if you don't want to, if you're a developer, if you're not an operation person, I don't want to know about like spinning up, like how to scale up or run a Redpanda. There's a Redpanda serverless. So sign up for Redpanda serverless, you get a free tier of like topics running right away, and we have a lot of sample code on it. And then there's Redpanda University, which I constantly update the content, so I manage the whole university courses. So if you have any questions, reach out to me, and definitely check out our Slack community, because our Slack community has all engineers in there. They will be happy to answer your questions, and it's totally free. So I'll definitely like meet you there as well.
All right, cool. For the sake of time, what do you think is like the next big thing? It's basically the last question I always ask. Like, could be in streaming, could be in databases, could be in AI, could be in.
I'm glad you brought up AI because everybody's about AI today. How do you not do anything with AI today?
I have my own opinion about that.
Me too. I need some AI detox, but okay. But anyway, but we are so for the connectors I just mentioned, we are adding a few AI connectors on it, so you can seamlessly, declaratively, without writing any LangChain code. You know, like LangChain has write a lot of code, but you don't. So it's basically easier for you to stream your data and then put your. You can actually stream your unstructured data, and then breaking it down to embeddings, and then put it into a vector database with all done in a declarative way. So you don't have to do anything. So we're just preparing you for enabling you to get your data into AI ready state.
All right. Interesting. That is cool. So you basically put the whole pipeline together, like the transformation pipeline, in a declarative way. Oh God, I'm not good at talking today. I mean,
like for unstructured data, because you can do some chunking and then you send it to embedding models and then you store that in a vector database. But for streaming data, it doesn't have to be 100% doing chunkings, depending on what you want to do with the data, of course. But so for us, it's just like getting your data into embeddings. It turns it so basically you just configure, hey, I'm calling this embedding model, and just turns it into embedding and then put it in the vector database. It just stores in the vector. So now it supports like Pinecone, and then it supports, like OpenSearch. It supports, all the Mongo and Atlas and all that. It just supports all the vector databases.
Everyone that has vector database support these days. So basically everyone.
Most of them are like Postgres, like Postgres vector, right?
I'm a Postgres guy. I'm okay with PG vector.
Which is great, right? Because you don't need to learn too much. Like everything like is there, which is awesome.
Which is one of the things that I find personally like very attractive to the Postgres ecosystem. That because Postgres itself is like so extensible, you have everything. I mean, PG vector is not the only thing. You have geo information system support. You have a graph database implemented as an extension to Postgres. You have the key value store. You have JSON or document store. You have I don't know. And in the worst case, I mean, you don't want that to be done in production, but in the worst case, you could put everything in a single database and have a single query across all of those like multi-model tables, which is, I mean, if we're talking about a multi-model database, Postgres is probably what you're looking for.
Exactly, right?
I don't think it was meant that way, but it kind of developed, and it makes sense, right? Sometimes you just have like small pieces of specific data, and it makes sense to just throw it in as well. If you figure out you may need a bigger graph database, hey, there's options. It's always good to, as you said, it's always good to have options.
Yeah, exactly.
All right. Cool. Yeah. Thank you for being here. Is there anything else you want to let the audience know?
Oh, that's good. It's thanks for having me here. I hope to see you again. And then don't forget to check our Slack community. I'm there.
Okay, perfect. That's a great one. Oh, and don't forget to go to the getting started pages, right? And the university and what
and everything I just said.
Right, and everything you said. Okay, yeah, cool. As I said, thank you very much for being here. It was a pleasure having you. And for the audience, you know where to find us. Same time, same place next week. And I hope you listen in again.
And subscribe.
There you go. All right, thank you.